Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISIM Stat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IITJM MS, ISIM Stat, and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
For a given sequence, we have to know the limit L beforehand. See, this was developed when they applied it on known things. Okay, great. So we will see a method in the future called Cauchy sequence where we don't need the limit definition. That's why that Cauchy sequence was defined, because limit, if we don't like, if we may not know the limit, it's going to be a bad function. Okay, so Cauchy sequence really helps in that time. Okay, so given that you understood that our goal is to find a limit, and how do we find the limit, and what is the meaning of the convergence, okay, to a certain limit. So let's also talk about divergence now. Like divergence to plus infinity or minus infinity. It's very simple. Let's talk about plus infinity. It's very simple. What is infinity? Can someone define infinity? So infinity is nothing but an object, mathematical object. You can not call it a number. It's not a number because infinity isn't valid like the largest number. You're right, Anand. So it's not a number, but because it doesn't follow the the arithmetic numbers we saw that on the first day, right? Infinity plus one is not infinity. Something different. I understand. So infinity plus one is infinity. So therefore, it doesn't it's not a number. It doesn't behave like a number. Infinity is a different object of its own. But you can say infinity is nothing but anything. Infinity is a mathematical object which can be attached to a real extended real number line, like you can attach infinity to a real number such that it's greater than any real number, the largest possible number, not number or mathematical like object, you can say largest possible, like any mathematical object that is larger than any real number, that is infinity. So that is essentially reflected over here too. So for all epsilon greater than 0, there exists an epsilon. So an epsilon is a bound after which it happens such that an is greater than, not for all epsilon, for all real number greater than 0, n is greater than L for all n greater than equal to n epsilon. This will be R. This is like a selection of that point. This is like after that, whatever happens, okay? This one. And this is like the point after which it happens. So you understood? This is essentially it's coming up. The n is greater than L. So I hope you understood this. I mean, it's not hard to understand after if you understood the previous one. But something I observed weird over here, a weird observation. I'll tell you the weird observation, but let's do an example first. Example. Example is, let's do an example. Let's try to do two examples. Fn is equal to 1 by n and Fn is equal to sin n by n. Okay. We have seen both of them are going to 0, right? So it goes, so we know the limit. So let's try to, so therefore what you have to show, you have to fix an epsilon. That's the first step. Then take the format like this is the step of the proof. Take mod an minus l less than epsilon, this quantity. So write it down properly in terms of the function, which turns out 1 by n less than epsilon. Now what you do is simple. You take epsilon, you get epsilon greater than 1 by n, right? Or sorry, n greater than 1 by epsilon. So observe, for this happens when this like implies, that means this is happening. That means for sure, I mean it means that not only like, it does not mean that if n is less than n 1 by epsilon this will not happen. It means that if this happens, for sure 100% this is happening, this one. And this gives an idea of the n epsilon here, that for this to happen, so we want what, for epsilon fixed, we want an n epsilon such that this happens for all n greater than that. So this is the n epsilon for all n greater than that, it's happening. This one is happening. That's like what, it's like a reverse way of finding it, reverse engineering. So finding the limit is a reverse engineering method, like finding the proof. And therefore, what do we see, that we get n epsilon to be n greater than this. So let's take the upper bound of this, like the greater like ceiling function. For n greater than n epsilon greater than equal to this, observe that an minus l, that is 1 minus n minus 0, is less than epsilon. So therefore, the goal of yours is nothing but to find n epsilon. That's the goal. Okay, that's the goal. Finding the n epsilon. All of you understood this example?